let's do requirement 1b. Information on how to play is presented. So, the first thing is, I think this is quite a simple requirement. We just have some kind of information that needs to be presented. We're doing a console application, so it will be in text form, this information. So some kind of text on how to play the game should be displayed in the console. So in our architecture, where should this responsibility be? Responsibility to present stuff for the user. View. So it's not a model responsibility to display things. Displaying is clearly something that is supposed to be in the user interface, and the view should probably be the one that is responsible for having the information and having knowledge on how to present this. So let's add it. So, just echoing out a short menu of stuff. Maybe we should have like small p there to be clear. Basically, you can start a new game. You can get a new card by hitting, and you can tell that you don't want to get any more cards, and you can quit. So it's quite simple. So, okay, we have allocated the responsibility of displaying instructions to our console class. This is, of course, not a class that we can find in the domain model because it's a software concept. So often we have the domain model classes inside the model in the model view controller pattern. But you can also invent new classes, of course, if they are needed. But this is a pure invention that we have kind of like done to create a software program for this. So, but we also need someone to tell the console to, okay, actually present this. In our architecture, the controller is managing how the user interface behaves and directs the model to do certain stuff. So we should probably add a controller to actually tell the view to show this type of instruction. So let's do it. All right, the next thing to decide is how does the player get access to the view? So we can create an object. we can try this type of solution. All right, so this is definitely something that would work. So this is one option, to create the object when it's needed. So yeah, we could do this, definitely. Do we have any other options? As a parameter, exactly. We could opt to send it in here, view, and move the responsibility to create the view to the program. Send the view in here instead. And do it like this. Same behavior, same stuff. So how would this look in a class diagram? Both of these solutions will look the same. What kind of relationship will we have between the controller player and the view console? We will have a dependency. We will not have an association because we don't have a member variable or attribute here in the console class of type here in the player of type console view. So this will be a dependency, and exactly the other one will also be a dependency. We're just creating an object locally in the play game operation and then throwing it away. So which one should you go for? And we could of course add, I would like to add this view console as a member here, and then we will get the association. So which one should you go for? Well, the answer is not cut in stone. You could of course do it in any of these ways. Right now the view is very simple. It does not contain anything that is actually needed to be remembered for a long time. It's just kind of like a function, more or less. But it will probably grow. It will be more functionality in it. So possibly there will be some kind of state inside the view also that is needed to be remembered. So if we then create a new view object, we will kind of like lose this state all over. So creating a local variable in this case is maybe not the best choice. So the choice is more or less between sending it in as a parameter or keeping it as an attribute instead. Right now, I think keeping it this way is the best, because we don't need to remember any, we don't have any other functionality in the controller than the play game operation right now, and we don't need access to the view in any other function that we are not kind of like calling directly. And also you could think about responsibility of creating the view. Who should have that responsibility? So you can think about this problem from the creator standpoint also. And I think it would be a bad idea if the controller had this responsibility, because this would tie the controller quite tightly to a concrete view. The architecture as it is kind of like couples view and controller tightly by default, so adding more coupling is probably not a good idea. So the responsibility to create the view should probably not be put in the controller. And instead we have this kind of like outside program class that is kind of like responsible for starting things up. And while in the architecture we need some kind of a model representation, a view representation, and a controller representation, and we need to put these parts together in some way for stuff to work. Next requirement. Well, let's just do the quit also, so that we have some form of input into the game. The responsibility is once again to collect some form of input from the console. Where should we put this responsibility? In the view, exactly. It's kind of like low-level knowledge about the console. We have this already in this form. So, okay. We can do something like this. We can collect the input, and we also need to kind of like transform this into an event that someone can handle. So let's just something like that. And so who should have the responsibility to ask the view if the user wants to quit? The controller. So after we have presented the instructions using the view, and we can use the view again to just ask if we want to quit, and the operation was this. And I will just kind of like oops. So if we input anything else right now than quit, we just display this main instructions over and over and over again. All right. Progress. So we have actually implemented 2 requirements of 3. So 80% done, or maybe not. But we have actually used a new pattern here. We have used the controller pattern, and things might get a little bit confusing now, since we're also using the model view controller architecture. And this is basically the controller part in this architecture also, that is a GASP pattern. So a system event, that is something major that happens in the system. For example, I would like to quit. I would like to start a new game. I would like to get more cards. I would like to not get more cards. I would like to add a new member, add a new boat. Major stuff that happens, not, oh, I have now inputted the character 1 in my phone number. So low-level input are not system events. You can think of it as, well, I have completely filled in the form right now, and now I press that I actually want to do this action. I would like to add the new member, and all the information is available to do this. So, the idea then is to assign a responsibility to a class that represents the system as a whole. So we have kind of like one big controller for the whole system. This is often called a facade controller. We can have a class that represents a role, a use case or scenario or session. This is basically what we did. We named our new controller class player, and that is an actor in the system that has a role. And we even named the operation play game after the most major use case or scenario in the application. In this game, it's probably the only scenario also. So we used this second solution to this problem. Or you can have a class that represents an input device. This is probably more common in more low-level controllers and controllers that if you have some kind of special input device. So, but we used this, we used the role, player, and we used the name of the operation, play game, to represent the use case. So we used this controller pattern to solve this problem also of responsibility assignment.